Welcome to the course. This is the very first lecture, and in this lecture I'll give you a short introduction to this course. I'll tell you what the course covers, how it is structured, I'll mention the different types of content that you'll find here, and I'll let you know what to expect in terms of goals you want to reach. So the course is structured into several sections, and sections are nothing more than logical groupings of several lectures. Now, for instance, you are at lecture 1 of section 1. And so in the first section I'll mention a few facts about Python. Then I'll show you how to install Python version 3 and where to write and execute Python code. Then in section 2 you'll learn how to declare and use variables. You'll also learn how to use numbers and strings, which are two basic data types in Python. Then once you've learned variables, numbers and strings, in section 3 you'll be ready to write some tiny programs using conditionals. Also in section 3 you'll learn how to write your own functions. And once you have a good grasp of custom functions, you'll already start to feel confident in writing lines of code. Then we will jump over to section 4, where you will learn some more complex data types that are lists, tuples, sets, and dictionaries. Then you'll practice these data types as you learn how to perform iterations using the for loop. In section 5, I'll go over to some more practical concepts, where you will learn how to create and open files and write content inside these files. In that section, you will also be practicing iteration, combined with file handling techniques. And then I'll explain to you all the functionalities that I mentioned above while typing code, executing and getting the code output. However, some things you will be able to understand by yourself by completing the exercises which you will find as you progress through the course. That's an excellent technique because it will keep you very active and will help you code independently with confidence. There are also interesting quizzes in the course that will continuously test your knowledge. And once you have learned all the building blocks of the language, I'll show you the way how you can apply that knowledge for making Python programs that will solve your problems in your specific professional field. So I'll show you how to look for special Python functionalities and how to use them for programming with Python. And moreover, we will be building some real-world small programs, and then I'll ask you to improve those programs so that you understand them better and learn how to do them by yourself. And lastly, I'll show you how to make your Python programs more user-friendly so that other people can also execute them. And to sum it up, regardless of the field of technology where you're planning to use Python, this course will get you up and running fast with Python. So let's roll and see you in the next lecture. So in this first lecture, I'm going to tell you a few words about Python, such as what Python is, what it can do, what fields of technology can Python be used for, where Python stands among the other programming languages, and how Python has become so popular. So Python is definitely not a large, heavy-bodied, non-venomous constrictor snake. It is a powerful high-level programming language intended for general purpose. So a high-level language means a language that enables the development of a program in much simpler way as opposed to low-level programming languages. Python, as many other programming languages, is a high-level programming language. So with Python, you'll never have to think about low-level languages. I said earlier that Python is a general-purpose language, and it really is. The language is used in many fields. According to the official Python webpage, these fields are web and internet development, scientific and numeric, education, desktop graphical user interfaces, and software development. And as you see, Python covers probably everything that can be done with a programming language. Python is a simple, readable and efficient language. If you were to create a program, you'd create that program with much less lines of code using Python than using a C language, for example. And on top of that, those few lines of Python code would be more readable than the C code. And all of that makes Python a very enjoyable programming language. And I bet you'll enjoy whenever you'll be given a new problem to solve with Python. Python was conceived in the late 1980s, and Python 2 Version 2 was released in 2000 and Python 3 was released in 2008. Python 3 is the latest release currently. That is the version we are using in this course. Today Python is one of the most popular programming languages and its popularity is increasing. So how did Python become so popular? Well, I already mentioned readability, so that's one of the reasons why people like and choose to program with Python. But also Google is using Python and YouTube was written in Python. Also, Python has a great community that is always ready to help. Other reasons for the popularity of Python can be specific for certain communities. For instance, Python has a great support for data analysis, and you can do whatever you like with it to your data. So if you're taking this course, it's probable that you have decided to learn Python for handling data. And I'm sure you'll learn a lot and we'll have a lot of fun programming with Python. I believe all you need is time management. So welcome again to this course and talk to you in the next lecture. Welcome to this new lecture, and I assume you have already taken the previous lecture where I talked about Python in general, and the other lecture as well where I showed you how to download and install Python and the Spyder environment and the IPython console as well. In this lecture I'll tell you a few things about the Spyder environment, as that will be the environment from where I'll be writing and executing the Python code. So the platform we're looking at is Spyder, and Spyder stands for Scientific Python Development Environment. Don't get scared by the name. Spyder is just an environment where you write and run Python code. So Spyder provides an editor here on the left and an interactive shell here on the right. The interactive shell is provided by IPython. So IPython is an enhanced shell where you write and run Python code. So IPython is like the basic shell that you can access through your command prompt, but with some added capabilities that we will discover together as we move through the course. You can also access IPython through your command line by just typing IPython, and you get the same console with the same functionalities as the one you have in Spyder. But I would suggest you use the IPython through Spyder because you have everything inside one single environment. So to write scripts of code, you should use the editor here on the left. And I have another very short lecture where I'll teach you how to run scripts of code. To program interactively, you use the shell on the right. So programming interactively means writing and executing single lines of code. This is done mostly when testing and where you're not intending to save your scripts of code. For instance, let's instruct Python to print out some text for us. So the function that prints out text is print, and the text we want to print is displaying some text. And so we get the text displayed as soon as we hit enter on the keyboard. So that's what I refer to as interactive programming. You can open multiple shells or consoles here if you like, but normally you'll not have to do so. You can choose to show or hide these two panes by going to View, Panes, and then click the pane you want to show or hide. So if I check the editor will hide, and I have a full view of the IPython shell. You could also modify the way Spyder looks by going to Tools, and then to Preferences, and here you have quite a lot of displaying options that you can play around with. For example, I may want to remove the header of the IPython console, so I go to IPython and uncheck that option. Now the next time I open Spyder, or even if I start a new console now, the header will have disappeared. There are also options that may become useful when you're managing big amounts of code and script files, but you don't have to know about them as far as you're not building big programs. So I think this is enough to know for now. In the next lecture I'll start writing code right away by explaining the basics of Python. So talk to you in the next lecture. Well, you should already know that variables in programming are simply some sort of containers where we can store everything. As in other programming languages, in Python we can store numbers, text, lists, files, data, and all kinds of objects. It is very easy to create a variable in Python. Just pick a name for the variable and store something on it. I am creating a variable here and assigning it a number. So, potato price equals 3. And yet another value in this other variable, amount equals 2.5. Notice here that we implicitly declare the data type stored in the variable. In many other programming languages, you'd have to write something like int potato price to declare that the variable will be an integer, so int stands for integer, and after that you'd store the value inside your variable. In Python, however, you don't have to write that much. Indeed, if the number you are assigning to your variable is a whole number, Python understands that and makes the variable an integer type. But I'll tell you more about data types in the next lectures. For now, let's check the data type that our variables hold, and we can do that using the type function. So we're gonna print out the type of the data that our variables hold. So to do that, type print and then open brackets, and inside the brackets we'll write what to print out on the screen. So in this case we want to print the variable data type, and the data type is generated by the type function. So type, and then we pass in the value in the type function, which in this case is a potato price variable. So Python tells us that the value of the potato price variable is an integer. And also let's check the other variable as well. Print again, type, and then we enter the other variable. And the value of the other variable is a floating point number, called float for short in Python. And I'll tell you more about data types in the next lectures. And a few more stuff now. You can assign any other values in the existing variables as well, even different data types from what the variable currently holds. So here I'm gonna assign a string to my potato price variable. Strings are like text, but we'll cover that later. So potato price equals free for today. And the variable will have discarded its previous value by keeping the new one. Functions, functions, functions. There are two types of functions, built-in and custom. Built-in functions are functions that have already been created by Python authors and are ready to use from Python programmers, which is us. The print function is an example of a built-in function. But in this lecture we're gonna talk about custom functions, and custom functions are super useful. I'll refer to custom functions as just functions from now on. So a function is an algorithm written by us that computes an output given a certain input. The key benefit of function is that you can write a function only once, but you can use it as many times as you want by just calling it, which is very simple. Here is how to write a function in Python. I'm gonna create a function here that calculates the cost of potatoes given the price and the amount. So we use the keyword def to tell Python that we are about to define a function, and after that we choose a name for our function. I'll name my function potato cost. Once we write the function name, we set the input parameters for the function, and we can now write what the function will compute and what it will return as an output. In this case we want to compute the cost of potatoes given the price and the amount. So cost equals potato price times amount. And we also want, let's say, to print out the potato type. Now we are printing out the potato type, but we also want to return the calculated cost when the function is executed later. We can either do it using the print function, or we can use the return keyword. I'm using the return keyword here. And see now how easy it is to call the function once we have created it. So potato cost, and we write the values, which are called attributes now. Notice that we are inputting values for each of the parameters in the given order, And what we get is the printed potato type and the computed cost. You can now execute the function as many times as you want using different values. And the last thing to mention here is that we wrote our function in the IPython console. As I have told you before, this is a platform for testing. If we close the IPython console, we will lose our function definition and we'll not be able to call it anymore. So normally we want to store our function in a script for later use. In that case, we have to write it in a .py script. Once we do that, we can reuse the function in the future. So that was how to define and call a function. As far as data types are concerned, we have so far mentioned integers, strings, and floats. Now you're gonna learn two other data types that are lists and tuples. Both lists and tuples are often referred to as sequences because they are sequences of objects. Let's start with lists. Lists are the most important between the two. So let's start talking about lists. A list is a sequence of objects, and these objects can be numbers, strings, files, and many other data types. Let's create a list of integers. I'm gonna call my list file list and add 3 integers in the list. Let's quickly see what we got. So it's a list of integers. Now each value of the list is called a list item. Lists are extensively used when automatically performing multiple actions, or iterating if you like. If you want to add more items to a list, you can use the append method. So append is a list method that adds a new element at the end of a list. And we use the dot notation to apply a method to an object. Now, lists are indexed, meaning that every element of the list, every item of the list, has a certain index starting from 0. So for our list, 2015 holds an index of 0, 2016 has an index of 1, and 2017 has an index of 2. Indexes are useful when we want to access certain items of a list. For instance, if we want the second element, we call the element with index 1. We write the list name and the index of the item we want to call inside square brackets, and we get the second item. And this item behaves just like an independent object. For example, in this case we have an integer, as you see. Now you saw that we were able to modify a list, and we did that by adding an item at the end of our list. Sometimes you don't want your list to be modified for some reason, and in such cases we use tuples. To create a tuple, just use this syntax. So to declare lists we use square brackets. For tuples we use round brackets. It is rare to use tuples, but in case you want your series to be immutable, tuples are always there for you. So you just learned what lists and tuples are, and more data types in the next lecture. As far as data types are concerned, we have so far mentioned integers, strings, and floats. Now you're gonna learn two other data types that are lists and tuples. Both lists and tuples are often referred to as sequences because they are sequences of objects. Let's start with lists. Lists are the most important between the two. So let's start talking about lists. A list is a sequence of objects, and these objects can be numbers, strings, files, and many other data types. Let's create a list of integers. I'm gonna call my list file list and add 3 integers in the list. Let's quickly see what we got. So it's a list of integers. Now each value of the list is called a list item. Lists are extensively used when automatically performing multiple actions, or iterating if you like. If you want to add more items to a list, you can use the append method. So append is a list method that adds a new element at the end of a list, and we use the dot notation to apply a method to an object. Now, lists are indexed, meaning that every element of a list, every item of a list, has a certain index starting from 0. So for our list, 2015 holds an index of 0, 2016 has an index of 1, and 2017 has an index of 2. Indexes are useful when we want to access certain items of a list. For instance, if we want the second element, we call the element with index 1. We write the list name and the index of the item we want to call inside square brackets, and we get the second item. And this item behaves just like an independent object. For example, in this case we have an integer, as you see. Now, you saw that we were able to modify a list, and we did that by adding an item at the end of our list. Sometimes you don't want your list to be modified for some reason, and in such cases we use tuples. To create a tuple, just use this syntax. So to declare lists we use square brackets. For tuples we use round brackets. It is rare to use tuples, but in case you want your series to be immutable, tuples are always there for you. So you just learned what lists and tuples are, and more data types in the next lecture. In this lecture, you will learn about sets and dictionaries. Remember, lists and tuples were referred to as sequences. Well, sets and dictionaries are referred to as collections, because they are unordered collections of items. Let's start explaining sets. A set is an unordered collection of unique items, and remember, unique items, not duplicate items allowed in a set. We can create a set using curly brackets, just like this. Let's say file set, and I'll store 3 integers in my set. A simple and practical use of sets now is when you have a list that has duplicate items and you want to remove those duplicate items from it. Let's say you have this list, file list, okay? We have 2 duplicate items. And to make a sequence of unique elements, you have to convert it to a set object. And we can convert a list to a set object using the set function. When you do that, duplicates will be removed automatically. So we are sort of updating our file list variable with a new value in this line of code. This new value will be a set that is generated by converting the list object to a set object. See now, printing the file list will reveal that duplicate items have been removed, and we now have a set object, not a list anymore. And that is because we converted our list to a set. But don't believe me and check the type of the object always. So, if you want to retain your list data type, you can convert the set back to a list using the list function this time. So file list equals list, and we pass the set object to the list function. More data types now. Dictionaries. Let's try to explain them by making a comparison with lists. So in the case of lists, we were able to access items using their indexes. For dictionaries, we can access items using indexes declared explicitly by us. Here's a dictionary. I'll call my dictionary FileDict. We use curly brackets to define a dictionary, and then we write the index, a column, and the corresponding item. So don't forget that each item has its own data type. So if you use quotes for an item, that makes that particular item a string, and so on. The items in this case are 2015, 2017, and 2019, and they are referred to as values. So remember, values when we're talking about dictionaries. And the indexes are last year, this year, and next year. They are referred to as keys. So what we are dealing here is an object constructed by pairs of keys and values. Now, in the case of lists and tuples, we were able to access items using the default indexes. In the case of dictionaries, you can access the dictionary values using their corresponding keys. And that will return the value attached to the year key. Remember that once we opened the file, we had to close it later using the close method? Well, in this lecture, you're gonna learn a more solid way that closes a file for you once it has finished working with it. And this solid method is called with. So you will learn the with method in this lecture. Before we did this to open a file, we created a variable and then we used the open method to open a file. And then we use the write method to write something in that file. And later on we had to close that file. What you want to do instead is write a with statement. So to write a with statement, follow this syntax. Start with a with keyword, and then we write the open method, the file path, the writing method, and then the variable. The next line then is used to write the actions that we want to perform on the open file. In this case, we would like to write a line, for example. So don't forget to indent the second line. Again, we use indentation for the with method. And so how do we read this statement? Well, just like this. With the open testing.txt file, we perform the actions in the next line. The benefit here is that the with method will close the file for us once the action below it have been completed. So it's a very compact method that is highly recommended. So what you're looking at is a script you wrote in the previous exercise. And what you basically did there is that you asked the user to enter some input. So the user enter a longitude and a latitude value, and then you pass these values to the new point method. In this lecture, I'll show you how to actually generate a KML file out of a CSV file. This is a more efficient way compared to the previous method, so compared to the existing script you're looking at now, because using a CSV file you can actually pass many longitude and latitude values at the same time and get a KML file generated. So now you have to think, how do we get the data out of the CSV file? Well, I think I already told you that you can use the Pandas library to do just that. Pandas is a powerful data analysis library and it can efficiently read CSV data and manipulate them. So I'm gonna delete these two lines here, okay, and import the Pandas library. Great. Now the CSV file I'm talking about is this one here. So we have 2 columns and 4 rows, and I'm gonna keep my file here and my spider here. Good. So what we want to do now is create a data frame object. And we use a CSV method for that, and here we pass in the path of the CSV file. So now we already have the data of the CSV file inside Python, and we're keeping them in the data frame object. What we want to do now is create a for loop which will iterate through all these 4 rows, and then it will execute the new point method 4 times. So the new point method will get the longitude and the latitude values for each of these rows. So the idea is that we have to start the loop above the new point method. So let's say for lon lat in. Okay, so so far I taught you how to iterate with 1 variable but not with 2 variables at the same time. So you used to iterate with 1 variable through a single list. Here, to iterate with 2 variables in 2 lists, we have to use the zip function. So the zip function allows you to iterate through 2 lists at the same time. And now our lists are, the first list is gonna be the longitude column. So to access such a list, we call the data frame, and then in the square brackets we write the column name of the data frame, which is longitude. And then we pass in the second list, which is latitude. Great, that's the idea. Now you want to indent this line here. And we don't have any name column in our CSV, so I'm gonna delete this. And then the arguments that we pass here to the course parameter have to reflect the names of variables here. So I'm gonna pass loan and let, and that's it. We have something here. It says invalid syntax. Of course, we haven't added the colon here, and that's it. And we don't want to iterate through the save method, because the idea here is that we will create 4 points using the new point method. And then once these points have been added to the object, then we just save this object to a KML file. Great. Let's run now. And we have an error. So the error has to do with the longitude string. And of course I've passed it through the wrong name, because the correct name is longitude. Great, let's execute again now. And let's check the KML file. So now we should expect 4 points in the KML file. And that's how it is. So in this lecture we leveraged the CSV data to create a KML file. And you may never have to create KML files in your life, but you may have to process CSV files, and the Pandas library is a great library for that. And here you saw how to efficiently iterate through the rows of a CSV file. So I hope you learned something from this lecture, and see you in the next lecture. Alright, we have this Python program, which if executed, say Python and the script name, we get this graphical user interface, which works great and does the work. The problem is that if you want to give this program to someone else who don't have Python skills, or they don't even have Python installed in their computer, they wouldn't be able to execute your script and get the KML file at the end. So what you can do in this case is produce an executable file. And that would be a .exe file on Windows and .app if you are on a Mac. Then you can just give that .exe file to someone and they can execute it and get the results. So to make such a program, such an executable file, you'd want to use a Python library called PyInstaller. To install the library, you use pip. Alright, my PyInstaller was already installed there, so I can just go ahead and use it now. Notice that I am in the C temp directory, which is where my file is located, and now I can just call PyInstaller and then the tab to get the script name. Note that we are in the command line here in the terminal, so I haven't opened Python. And if we leave this expression as it is now, we would actually get a bunch of files, and among them would be the .exe file. This method is good in that if some problem happens, you would be more able to actually troubleshoot the problem and go to the specific file that caused the problem and then maybe solve the problem. But if you want a single file, a single .exe file or a single .app file for Mac, you'd want to add a parameter here called oneFile. And there's yet another parameter you'd want to add, and that's the windowed parameter. The windowed parameter will create a single window for your program, so without a command prompt on the background. And that's it. You execute this, and you'd have to wait a while until the process finishes. And that was apparently successful, but let's check. Your executable file should be inside the dist folder. And here it is. So, it's the same program. And does the same thing. If you want to give this program to someone, you can just send the .exe file and they will be able to execute it without needing Python installed. And that wraps up this section. Hope you enjoyed that. Thank you.